Hello and welcome to Getting Started with SQL Part 5. In this video, we are going to be looking at 3 keywords, limit, offset and order by. Very simple query keywords that become very powerful when you are trying to restrict the results that are turning, different from the where clause. I'll explain what I mean by that. And then we're going to jump to transactions. It's another thing that I do want to cover before we actually move to Postgres. And the reason behind using these is going to be we're going to expand the database out, our web store example, a little bit. What I've gone ahead and done to save me just racking my brain while I've got the recording running, I have created a new SQL script, as I do for every video. And I've created an insert statement for the products table. So I'm going to be adding another 7, I think it was, products here. So they're all going to be GBP. We're just going to be inserting these products into the products table to demonstrate the limit and offset keywords that we're going to be using. I am here in the select piece of the documentation, which is available from the alphabetical list of documents. So let's go ahead and run this statement and let's have a look at our products now. So we now have 12 products as indicated by the index on the left-hand side. Okay, so when you are returning information back to an application, there are instances when you may want to get all of the products back. Let's say it's your web store page. But if you think about a web store, you'll have options at the top: order by price, order by name, order by popularity. You'll also have, on some stores, show 10, show 20, show 50, show 100 items. And the key behind this is generally a SQL statement that's actually running in the background, and I'll show you what I mean. So we're not going to be doing any particular searching on popularity. We can sort by the price, absolutely. Let's filter out USD for now. So let's go ahead and just write that statement where currency does not equal USD. We have 11 results back, and first of all, we are going to touch on the limit and offset. So in this select documentation, we select the result columns from a table where we can group by, we can have windows, all of these wonderful things. But right at the very end of here, we have a term called, there's order by, but there's limit and offset. So what are these keywords? If I go ahead and type this out and we come into the expression, we can have all of these different values in here. For now, we are going to assume that someone just wants the first 5 results. So that will be the iPhone, the calculator, the pen, the toaster, and the playing cards. And to do that, we're just going to type limit 5 on this. There we go. That's all well and useful. However, if you scroll down to the bottom of this page, you've got your 5 items, 1, 2, 3, 4, 5. Scroll down to the bottom and you've got your page numbers. How do you then go to the next page? That is where the offset expression comes in. So we can say offset, I believe it's going to be 5. Reading glasses, mouse, keyboard, measuring tape, Raspberry Pi. We would then offset 10 to remove this last one, and we would get the last result. And what you can actually do is you can, if you're passing variables into this SQL statement, you can multiply this by the page number. So select star from products where currency isn't USD, will limit 5 and offset by 5 times 0 because we're on the 0th page. This will be a 0 index sort of thing. We would return page 1, but this is 0. This would return the first 5. If we multiply this by 1, that will get us the next set of results. Multiply it by 2. The 5 times 2 will be offset 10. Therefore, we'll return the 11th through to the 15th product. Also, we can change this. So we can say, if we only wanted 3, we can multiply it like this. So we can go ahead and say 3 times 0. That will bring back the iPhone, the calculator, and the pen. I believe the next one should be toaster, playing cards, and reading glasses. So let's go multiply by 1, toaster, playing cards, and reading glasses. Fantastic. However, we are relying on the default sort of this to return a value when we could be using the price. So to actually sort these values by a price, let's run this without the limit. We would expect to see iPhone at the top as it is. The next item would be, I think, the Raspberry Pi 2 GB. And we can write order by, and I will move this down a couple of lines so I don't accidentally run that one, price. And in the offset expression, no, sorry, we want the ordering term, not the that one. We can specify expression, don't worry about collation for now. We can specify whether we want ascending or descending, and if we had nulls in here, we can say whether we want nulls first or nulls last. So let's say we wanted nulls, price descending. This will now sort this data for us automatically with the highest price first and the lowest price last. Someone then clicks that little arrow at the top that says, actually, I want it in the other direction. We can change this descending to ascending. And that is going to invert the order that these are returned. Now you'll notice in here, do we have any? We don't have any products with the same price. That's annoying. Not to worry. Let's bring the currency back in. So I'll remove this statement with a comment, and we're going to order by price again. And this extra toaster has appeared in here. Let's say we wanted to move this USD value to the top. These order by expressions will be executed in order. So it will first sort the first column and lock those in place, and then within that it will sort the second columns. I'll show you what I mean. If I go ahead and run it this way, currency, we don't have to specify ascending or descending. I believe the default is descending. Let me see. ASC. If neither ASC or DESC are specified, rows are sorted in ascending, smaller values first order by default. So this will specify currency first. However, if I run this, nothing changed. And that is because it's already sorted by the price, got those in order, and there was no reason to sort this. It has sorted it, but they had already returned in the right order because GBP in an ascending term comes before USD. If I specify descending after this, you'll notice those two values will switch around. However, we wanted to move USD to either the top or the bottom. If I actually move this way, USD has now moved to the bottom because first of all, we've selected from products. We have ordered by the currency, and because G, the character code for G will come before U, so G will come first in an ascending. If I change that to descending, that will come last. Demonstrate that. U is there. Hopefully it's also alphabetical order. We are sorting by this value first of all, the currency value, and then we're sorting by the price. So you can see within the GBP sorting part of this, these prices are still ascending. If I change this one to descending, the iPhone should then be the second option. Yes, marvelous. You can then combine this if we bring back in this where currency does not equal USD. So we won't need the currency sort anymore. It wouldn't hurt to have it in, but we don't need it anymore. We now have our web page, return the prices highest to lowest, and we can then paginate those. We can go to the first page, which is indicated by the 0. We can go to the second page, which is indicated by 1. We can go to the third page, which is indicated by 2, and so on and so forth. And this is really useful because if you are running a web store and you just want to paginate your results as they're coming back, you can do so with the limit and offset results. So we have covered off nice and quick the limit, offset, and order by. The next piece we're going to move on to is transactions. And what transactions are a way of doing is preventing things from actually committing to the database. And committing is the keyword. I've got the documentation here available. It is, you are able to insert, update, delete things, and the data is sort of stored in almost a cached state until you choose to either roll back, where all of your changes are ignored and the database continues in the state it is, or commit that transaction. Be wary, and I'm not quite sure how SQLite handles this, but that can cause some table locking. So if you have transactions running and you lock a particular table for that transaction to happen, you can end up with a result where other people, if you've got multiple developers accessing the same table, or the application, if you lock a table, it may well not be able to insert into it if you've locked it. All of that will make sense down the line as you get to it, but just a heads up. But transactions are incredibly, incredibly useful. And I can demonstrate that quite easily with, if we do begin transaction, and that is how we would run it, or start a transaction. We can use deferred, immediate, or exclusive. We can also just use begin transaction, nice and simple. If I run this statement, we are now working within a transaction. If I then go ahead and say insert into products, name, price, values, product I don't want, and 0.00, and then select star from products, you will see that product I don't want has been allocated an ID of 19. It's got the name, it's got a 0 price, and it's got a currency of GBP. Now, if I run that outside of a transaction, to remove that product, I would have to delete that row. 19 would have been taken already. The next one would be 20. However, I can go ahead and I can say rollback, and we can optionally specify transaction as well. And then if we go back to select star from products, you'll see that 19 isn't there anymore. If I go ahead and run start a transaction again, and I reinsert that value, and I select star from products, you'll see that one actually obtained the ID of 19 again. The sequence, because that change was discarded, that sequence never incremented by 1. So 19 is still available. We can again roll back that transaction. And if you run rollback transaction when a transaction isn't active, it will tell you no transaction is active. Select star from products, and 19 is gone again. However, to demonstrate why that's actually useful in the real world, we are going to come back over to Excalibur, and I have prepared a slightly altered ERD diagram. So at the moment, this is the structure of our database. We've got products, customers, and orders. And if you remember, a customer could only order one product at a time. If they wanted to order multiple products, they needed to place multiple orders. And as we were building this at the time, I alluded to the fact we would expand this out in the future. And that's what we're going to do. So if I come across somewhere over here, we're going to change the structure of our database to have order lines. And an order line is going to relate to an order, which is going to have a customer, and an order line will have a product, but different order lines can have different products. Hopefully you're following along. So let's try and think about what we want this order lines table to look like and start to build just out a select statement for it. It will be useful for us later on. So what should order lines look like? I'm going to start with orders because as we're building out the order lines table, we're going to want to move some things from orders into order lines. First of all, we're going to want to know on the order line, what order ID is this order line relative to? So we're going to take the ID and we're going to call this as order ID. The next thing is we're going to know what product this order line relates to. So let's go ahead and grab the product ID. Don't even need to alias that, I think that's fairly self-explanatory. And then it would also be useful if people were able to order multiple of the same product. So let's have a quantity. But for the time being, we've only been able to order one, so we can say this is just one for now. This will make sense when I'm using this statement later on, I promise. I also thought it would be useful to capture what the price was when the order was sold. Because if you think in our products table, we've got playing cards for $9.99, but next year we might want to sell it for $10.99, for example. So these playing cards, as we're looking back through our history, if we're doing those joins we were doing in the last one, we were saying this order, we were getting the price from the product table, p.price. Actually, if we had the sale price on the order, we could update this price later on and the order line would be holding the price that it was sold for. However, we're going to need to get these prices. So I'm going to alias this table as O. If you remember, aliasing is just renaming the table for the instance of this query. We're going to join on products P, and we're going to join on o.productid equals p.id. And there we go. We should now have access to products. So we can say p.price and we can say p.currency. And let's have a look at what this looks like. So order 1 has a product, an order line, product ID 1. They ordered one for $10.99. Let's check if that's right. Order ID 1 had product ID 1 for customer 1. Fantastic. The other thing we're going to probably want to add is an ID for our order lines as well, so that we've got an order line ID to reference individual lines. So let's go ahead and start building this table out. And just for completeness purposes, I will pull up the create table documentation. Create table order lines. First thing is going to be the ID, which is an integer primary key auto increment. Hopefully that's nice and familiar by now. We don't have that in here. The next thing, one second, just get my formatting in place. The next thing we're going to want is the order ID. We know this is actually going to relate to the orders table. So in our create table statement, we're going to want our column definition and our column constraint, and we're going to say that foreign key clause references. So it's an integer, references, orders, ID, on delete, restrict. So we can't delete the order if order lines exist, basically. The next thing we need is the product ID, just up here. Copy that. And we also know that's going to be an integer. References, products, ID, on delete, restrict. Then we need the quantity, which is going to be an integer. And we want that to be not null. We need the price, which back in our second video, we specified this as a numeric. And we also want that to be not null, because at the point we're creating an order line, we do not want that price to be null. And finally, let's pull in the currency as well, which was a text. We're not going to default it at this time, if you remember, as we did last time, but yeah, we'll just say not null this time. So I think that's everything. The last check I'm going to do is make some space and check pragma foreign keys, because I've opened and closed this a few times. Yes, foreign keys are on. If you remember, we had to set that to on because it defaults to off in SQLite. We're creating an order lines table, which has the order lines ID, the order ID, the product ID, which are referencing the orders table and the products table, restricting if we try to delete either of those. We are taking the quantity, the price, and the currency. And let's go ahead and see if that works. Looks like it might have done. Order lines. If I pull this diagram up and we have a look at our view diagram and refresh this, we still have a, so if I move, let's try and get this in the right order, we still have a link between products and orders. And the reason for that is our orders table, if you remember, that's still holding the product ID, and that doesn't need to be the case anymore. It won't need to be the case in a moment, actually. We should probably go ahead and populate the products into here first of all. So to do that, we can use this statement. And if I go ahead and pull up the documentation for insert, we can actually insert into table name and then use a select statement. So we know that this plus an ID is what we want to go into this table, this order lines table. So we can insert into order lines. We're going to want the order ID, the product ID, the quantity, the price, and the currency. And then we can just copy and paste this statement. And that should, I believe, just go straight in. Let's give it a try. Looks promising. Let's have a look. Yeah, we've got some order lines. It's added the ID because we specified that to be a primary key auto increment. We didn't specify it in this insert statement, so it's automatically generated those for us. and then it's pulled back the orders 1, 2, 5 and 6 and the products that were ordered on those. So now that we've extracted this data out of that, the products that were sold out of the orders table, we can go ahead and alter table and drop the product table column, drop the product column. Not products, orders. Let's now have a look at that diagram. Can I refresh it from here, or do I refresh it from here? That has done a sterling job. Sorting this. But hopefully we have a one-to-many, a one-to-many, a one-to-many. We've got our customers, which the ID relates to the customer ID. So we know which customer placed each order. We know what's in each order because we store the order ID on the order lines, and we know what products are on those order lines because we have a direct link to the product table. So how do we now go about, if we go back to our last one, what we had here was a statement that looked at how many times a product had been ordered. How would we now adjust this to work with our new order lines table? In all honesty, we should just be able to, let's check this out, lines. So we've got the product ID. And in here, we will want to take the sum, I believe, of the O dot quantity, and then order lines. Let's make this OL, just so it's a little bit clearer. Last O has always been orders, hasn't it? So OL, OL, OL dot quantity. So we sum the order line quantity, and then we can sum the order line quantity and multiply that by the price. See what it looks like. 3 toasters, 1 iPhone. That looks like that's worked. However, how are we now going to insert orders? And then we'll test this statement again. And for this purpose, I think we've only got one customer still. Yes, customer 1, a@example.com. This customer is going to order 1 calculator and 2 pens. So we want customer ID 1 is to order ID 2 times 1 and ID 3 times 2. Hopefully that makes sense. We are going to need to think about how we actually start to insert this. So we're going to need 2 order lines because we have our quantity that we can use to specify the 2 pens that we're inserting. However, we also have order ID, which is a foreign key to orders. So before we create any order lines, if we try and just insert a new order line without the order existing, that's going to fail because that order doesn't exist. We don't have an ID for it. And this is where transactions come in. And the way this would work in a production database is we would go ahead and create the transaction to manage all of this to make sure everything inserts correctly. And if it doesn't insert correctly, we don't just want to remove the order lines, we also want to remove the new order that we've created, because otherwise you can end up with maybe an order, the order lines failed, maybe the order isn't complete, or the order doesn't have any products. Hopefully you can see how that could be an issue. We don't want to be creating this order unless we have order lines. Now this is where the point I wanted to get to with this is going to be quite difficult in SQLite without an application to manage this as well. And it's going to be a real push for us to move to Postgres because there are easier ways of managing this in Postgres. However, let's first of all create our order. Insert into orders, customer ID, values 1. Let's begin our transaction and insert into orders. Let's have a look at what we've got in orders. We have our new order created at, I'm on BST, obviously this is UTC, 1621 UTC, order ID number 7. Now, we want to insert into order lines. Let's go ahead and get our column names, paste those in there. And we can just use another select statement for this again, because we've got all the values in the products table. So why don't we do that? Select order ID is going to be 7 because we've created that here. And we could alias it, but we don't need to. Product ID. So the first product we were ordering was number 2. The quantity was going to be 1. And the price, we're going to select that from products, is going to be price and currency. And then we can just go ahead and say where ID equals ID2. Let's take a look at that. So this is the calculator. I'm not running the insert here, I'm just running the select statement because I haven't highlighted the insert into. That looks fine to me, that was the calculator. And if I run this whole thing, updated rows 1. If I then copy and paste this, we can then insert into order lines. Order ID, product ID was going to be 3 and we wanted 2 of them. So 3 and 2, and this is also going to be product ID 3. So we're just pulling back the pen, 195, but this is, tell you what, let's go ahead and alias these just so it makes more sense. Order ID, product ID, quantity. SQL in the background will just put them in the order that you put them in. So this is the first argument, it will go to order ID. This is the second argument, it will go to product ID. But for ease of seeing it, we can see order ID, product ID, quantity, price, currency. And we can commit that. And then we can have a look at our order lines. And you can see order ID 7 has product ID 2 ordered once, the calculator, for $24.99, and product ID 3 ordered twice for $1.95. So that looks pretty good. Let's go ahead and commit transaction, because at the moment we are still working. We've started this transaction. As a point of note, it doesn't matter. You could be running commit above begin. The order of these, if you're running them ad hoc, doesn't matter. All the time I haven't closed this transaction, any statement I run in this window is going to be in that transaction. Let's go ahead and commit it. And just for demonstration again, if I commit this, it will say no transaction is active, can't commit anything. Let's go back up here and see if we can see what's going on with this. So that, oh, we didn't group by. I was going to say that clearly hasn't worked. We have ordered one iPhone for $10.99, a calculator for $24.99, a pen twice for $1.95, and a toaster 3 times for $1.99. I'd say that's looking pretty successful. So, all in all, hopefully that helped to explain a little bit. The real challenge with this now is ideally we'd be putting the creation of an order into some sort of a function or stored procedure to manage that order creation process for us. SQLite doesn't really have those. You can create scripts, you can write them into your application logic, but this is where Postgres is going to start to be really powerful, and we can build a create order function, for example, for us that will go ahead and return us the ID rather than having to manually key it in. It's going to be a bit of work up front, but we can make our ordering logic more sound. We've also gone ahead and we've created this new structure in the database, so our 4th table with order lines. We're now able to change the price of a particular product, and it won't matter. So we could, to demonstrate that, I guess, go ahead and let's do this in a transaction so we're not actually going to commit it. One habit I've always got into as well is putting these in comments after this, so that if I need to revert a change quickly, I already have these statements available to me. And this is just a hangover from working on production databases where we did have to use transactions. But let's go ahead and have a quick look at the products table. And our pen is 195 ID 3. So let's update, pull up the documentation for it. Never going to find it quickly. 200. I'm really never going to find it quickly. Update table name, set column value, update products, set price equal to 1,000, where ID equals 3. Begin transaction. Update products. Now, if we go ahead and run this statement that we built, how many times has a product been ordered? Interesting. Okay, so I did have an error in this statement. We want the order line.price. There we go. The price hasn't changed. Historically, when we were doing this check, we were actually checking against the products table, and I completely missed that. But because we've now saved this price, I think we've got the price up here as well, order lines.price. We can see the total value these pens were sold for was 195. We had 2 of those for 390, and we are going to go ahead and just roll back that transaction so that change isn't in effect, and we can see that with the pen still being 195. If I run this again, there are no transactions active. Cool, minus that little blooper. I'm glad we checked that. There are no other things I wanted to cover within this video. The next video, I think it really is time we move into Postgres, something I'm a bit more familiar with, and we will be able to start or continue building out this to be more functional, perhaps pop a little application on top of it as well, rather than having to manually enter all of these values. We'll see where we get to. Thank you very much for watching. Any questions, drop them in the comment section below, and I will see you for the next video when we start working with Postgres.